Hello and welcome everybody. I'm Ettore Volpicelli, in charge of developer marketing here for our region, Europe, Middle East, and Africa. I will say welcome back for the one that maybe participated to the previous session on cloud native office hour with Hassan Ajan, so that he's our speaker also for today. I want just to give you a spot on the next big conference that we are going to host, Developer Live on MySQL, the 15th of October. So as usual, I invite you to register for the event. There are 10 sessions plus a keynote and 2 hands-on lab, live hands-on lab. But today the focus is on cloud native. We have Hassan. Last time, the session that it's in any case available on demand was about why choose cloud native. And today we are going to have the practical approach to cloud native. So Hassan will go through the solution and give to us an example on how to deploy. So Hassan, hello.
Thank you, Ettore.
You're welcome.
Thank you so much, Ettore. I'll take over and share my screen once you stop sharing. Perfect.
Super.
Okay. Is it the right screen you're seeing, Ettore, or is it the wrong one? I believe it's probably the wrong one, right? Let's try again.
It was the PowerPoint.
Oh, okay, perfect. Excellent. So thanks everyone for joining, and thanks for those of you who joined last week or last time will probably know, got an intro. What I'll do today is I'll give a quick intro as well to what we went through last time, just so everyone kind of have an idea of why cloud native is important as well. Very short about myself. I'm working as a principal product strategy manager at Oracle, focusing on OCI. And I've been, before joining Oracle 5 years ago, I used to be a system admin focusing on basically setting up Linux and automation. And that's basically where my interest in this is coming from. So today's program is basically looking at a little bit about what CNCF is, what is cloud native, because it's massive. So we'll have a quick look at the landscape just to get an idea of what is it we're dealing with today. We'll also then we'll go practical and we'll spin up a Kubernetes cluster. We'll deploy a sample application using the Kubernetes files. Then we'll use Helm charts, and I'll explain a little bit more about what Helm charts are. And then we'll deep dive a little bit into what Kubernetes resources are, and then two really important aspects of this as well: operators and service brokers. So this is a lot of stuff for 45 minutes. I'll try to do my best at covering it, and as well as possible, so you actually get an idea and can use this afterwards. If you have any questions, feel free to ask them in the chat. So in the previous session, we spent 45 minutes explaining, why cloud native, etc. So we're not going to do that today. But in short, it's about being able to, manage your setup, your infrastructure, your deployment, your applications at scale, be able to scale it up at large, and at the same time, keeping it manageable. And you do that, of course, through automation. And obviously, it's not only, containers that you can do it, but you can also do it with things like automation, which is, for example, Terraform. So if you're not into containers, but still looking for an agile way to manage your infrastructure in a smart way, you can do that with in alternative ways as well. But today the focus is containers and cloud native. Now, so one of the main things that you'll get out of this is, and if you do it right, is to be able to spin up your environments over and over again, whether it's production or test or small environments, but the full stack, and that includes load balancers, block volumes, any resources that are part of your application or part of the cloud infrastructure. All of it can be automated and spun up together with simple scripts, and that's what we're going to look at. Now, to look at the life cycle of, and this will be my last slide before I actually jump into the actual demo. To look at the life cycle, let's imagine this is your application, has a front end, a back end, and some search service. And you want to containerize that. The way that would look like, so what would happen today is if you had an app and you want to go cloud native or you want to containerize that, first of all, you have to start with building a Docker file, so containerizing your app. So that's taking a Docker file and putting in the steps that are required to build a container with your application inside of that. That's not part of our exercise today, okay? But that's a prerequisite for what you'll see today. And you'll also have to push that image over to the container registry where you'll store your images, your Docker images, okay? Now, let's imagine we've taken all these three applications, the front end, the back end, the search service, and we've put them into containers, and we have them as images now in our container registry. The next challenge would be, how can we take all these three and deploy them and make sure that they have, the configuration variables, they know the IP addresses of each other, the endpoints, username, passwords, all these things needs to be shared across. And this is really, and again, this is what we discussed last time. This is really what's part of Kubernetes and how it helps with the scheduling, it helps with the configuration management, i.e., sharing those IP addresses, sharing those configuration variables through environment variables that needs to be available to all the different parts. The result is a full stack that's deployed once you deploy it. And the way you can do it, and one way to deploy these applications full stacks in a really, really nice way, and a fantastic tool, which I truly love, is Helm. So Helm charts, and that's really the main topic, and that's what we're going to see today, and that's what we're going to play a little bit with. So Helm chart can help you basically define your infrastructure, define what it should look like, and then use it to deploy and spin it up. And Kubernetes will then take care of the rest, making sure they continue to stay alive, making sure that if any health tests fail, it will shut it down, etc., etc. One last part is service brokers, and I'll get into that later on. So let's jump over to the more practical aspects. So, like I promised in the beginning, we should look at the CNCF landscape to begin with. As you can see here, it's really, really overwhelming, right? There's so many different tools. I think the most important here is to kind of look at the different labels out here, right? So provisioning, runtime, orchestration management, application definition and deployment, database, streaming and messaging, application definition, image build, CI/CD, service mesh, API gateways. So kind of get an overview of like the different categories, that exist out there. It'll probably take you like a few months, if not years, to get familiar with all the different services that exist in the space. And obviously that's not our purpose today. Our purpose, and what I'm trying to say, is that we're going to be touching on different parts of this. I won't be mentioning like where we are right now and how the network and is managed underneath the Kubernetes that we're using, etc. Because this is meant to be a practical approach. So we just want to kind of give you a few hints of how you can get started to get hands-on with these things. So without further ado, one of the first things that you need is a Kubernetes cluster. You can either go to Minikube and get that started on your local laptop. You can spin up a Minikube Kubernetes cluster using Minikube. It'll give you like pretty much everything that you'll have in a real Kubernetes cluster. So you'll be able to have persistency, load balancers, services, etc., etc. So it's a really nice way to simulate all this stuff. Now, one thing that might happen is if you don't have enough resources on your laptop, you might get into trouble. It might go a bit slow. I'm using Oracle Kubernetes Cluster in this demo. So first step is to spin up a cluster here. So I'll go to Developer Services, Kubernetes Cluster, and it's pretty straightforward. There are two ways of doing it. I can do a custom, cluster, which will, if I've already defined my network and I want to do that manually. But if I don't want to, bother with creating the network and the internet gateway, etc., I can use this quick create. The quick create will simply ask me about what sort of version of Kubernetes I want to deploy, and then whether I want the worker nodes to be in a private subnet or public subnet, and then the shape of the worker nodes. So basically, initially it will be created with this one node pool, and later on you can create other node pools with other shapes. I have like 3 nodes by default, basically, that I can have. The idea is that the nodes, the worker nodes, this is where your application will run. So you should have 3 at least, which will make sense because then your applications can be highly available. And if you make sure that you have enough replicas, Kubernetes will make sure to schedule applications on these different nodes. Okay, so once that's done, I spun up one before this session here, just to make sure that we don't have to waste time waiting for it to come up running. And it's here. Now, what do I do with this? Maybe just as an information, the management part of the Kubernetes cluster is managed by Oracle. So I don't need to worry about this part here. I don't need to worry about etcd and all the other moving parts. All I need to worry about is basically the VMs, which are in the node pool. So here you see I have pool 1, and I have 3 nodes in this node pool. So these are my 3 nodes where my services will be running once I deploy them. So jumping back to the cluster, we have this quick start here, which I will use. So I need to access the cluster first of all. That has a few prerequisites. There's 2 ways to access the cluster. I can either use Cloud Shell access or local access. So if you want to use your, let's say, your own shell on your laptop, then make sure to have OCI CLI tool and kubectl installed. You need both. And then you need to run these commands. What this will do is basically it will download the configuration for Kubernetes, the token, etc., and it will place it in kube.config. So after that, you can both use the OCI tool and you can also use CLI tool, and you can also use kubeconfig. What I'll do is I will use Cloud Shell. Cloud Shell is basically like a shell that's in the browser, so we don't have to use my local shell. And let's click Cloud Shell here and run this command. I believe I've already done this, and let's maximize this. So I just pasted this command here in Cloud Shell. I don't need to do any additional stuff. Like I said, locally you'd have to install the OCI CLI tool and kubectl. Now this should create config, existing config file found. Fantastic. So it's already there. Now I want to speak to my Kubernetes to see what's going on. One of the first thing I can do is say kubectl get nodes. That will show me what worker nodes are part of my cluster. So telling me 3 nodes, and these are the APIs, and they're all ready. Fantastic. So let's go back to the instructions and see what else we can do. The next thing that we suggest here in the instructions is to deploy a simple app. The application that's here, this is an application. It's hosted. The YAML file for this is hosted, so you can look up this file and look at what's in it. It's basically a deployment file. This is a standard Kubernetes file for deploying an Nginx. And if we run this here, it should start. We should pull Nginx and then deploy that to the cluster. So it says here deployment created. Now, if I say kubectl get deployments, we should see it here somewhere. And you can see it here, 14 seconds ago, Nginx deployment. What we could also do is say kubectl describe this Nginx deployment. And this will tell us a little bit about what's in there. Oh, I missed the deployment part. So kubectl or Kubernetes has a bunch of resources, and I have to just define what sort of resources it I want it to describe. It could have been a pod, it could have been a service. So in this case, it was a deployment. So what we've done here is in the YAML file, we were telling Kubernetes what state we want our application to be in, and it's taking that state and then it makes sure to execute on that. And this is all described here. When I say describe, it gives me all the details. So we can see here, it's a container. It's based on an image called Nginx. The images here are typically found on Docker Hub. So those of you who worked with containers before, you might know Docker Hub. Those who haven't, Docker Hub is basically like a repository for, I think, 4 million images available with loads of containers that you can either use with pre-built, where the application might already be installed, or you can use them as a base for the images that you will build your application on. So for example, if you have a Java application, you could use the Oracle Java SC, for example, container. If you have a Rails application, you'd go and look for a Rails container or Ruby or etc., etc. So coming back to our cluster here, we can see that it's, like I said, Nginx, and available true. So the status seems to be, it just looks, replicas. We have 2 desired replicas, 2 updated, 2 in total, and 2 are available. So that's so far so good. So I could say kubectl get pods, and that should show me the actual pod which is running the container. Fantastic. And we said we wanted 2, and that's what we're seeing here. Basically 2 replica sets with 1 each. Great. Now let's do something else. So that was the first thing. Now let's try to say we want to deploy an app. Like I said, we wanted to use Helm charts. So, and I can see a few questions in the chat. Let's check them out. Okay, no questions so far. Fantastic. So Helm charts. So Helm charts is another way of basically deploying applications to Kubernetes. It's using a templating language, so you can create really, really advanced, let's say, templates without having to manage a bunch of files for deploying applications. And you can reuse them for multiple environments because they're using something called a value file. So you can simply change the value file where all the configuration is for a specific environment. So let's say we have test staging production. We're using the same sort of application. The application stack is the same, but the values are different. Like the amount of replicas I want in my test environment is not the same as I want in my production. Maybe the persistency is different. I don't necessarily want maybe persistency in my test environment. It might be a load balancer that you don't want a load balancer, or maybe it's the version number. So all these things can easily be configured, and you can define the whole stack, in a Helm chart. And you can also manage what versions you're deploying, etc. And we'll see that in a second. So again, similar to Docker Hub, there's something called Helm Hub. Helm Hub is basically a place with all these charts. Now the difference is, well, Docker Hub is like a single container. Helm charts are like a set of containers that are working together. So if we take the example of WordPress, now we know WordPress needs a database. So it's a PHP application that needs a database. And by deploying or using this Helm chart, we will get both things deployed in our container. So let's get going with this. First of all, I need to add this repository, this Helm repository, to my cluster. So the way I do it is say Helm repo add. So in this case, it's Bitnami charts. You can also create your own repositories for your information. You can create your own repository. So internally, once you've, let's say, reached the level where you have Helm charts and you build them for various applications, you can actually create like a little self-service catalog for the developers or anyone else who want to deploy the various different applications, and you can host that yourself. And it's the chart thing is an open source thing, so you can easily host it. We've added the repository. Now let's go ahead and install the chart. And if we just scroll down a bit, we'll see the way to do it is Helm install, and then give it some sort of a name for the release, and Bitnami WordPress. So that's what we'll do. In this case, you can see I don't have a name for it, so I'll just add name here and say test. And notice the version here. So it's also using a specific version. Now, I have a bit of output here, and it's telling me you can access your site here. This probably won't work because this is a local DNS, so this can only be accessed through the from inside the Kubernetes cluster. I obviously need an external IP. But it's also telling me that you can export the service IP by running this command, kubectl get service, etc., etc. So what it's doing here is basically getting the outputting the service in this namespace, for this specific installation that I just done here, and it's grabbing the load balancer IP. Okay, so it looks really cryptic, but it's not doing something very advanced. It's basically just adding the IP for the service here. So let's run that. We can actually run all three of them in one go. Let's see what happens. Fantastic. So it's probably assigned. So what we can do next is say echo these two here. And now we have the IP address. Fantastic. So we should be able to see a WordPress site on this link, if it's up and running, of course. So we can go back and check the status of this by saying kubectl get pods again. Okay, so the one that we just ran, you can see here it's pre-fixed with test, and the database in both of them are not running yet. So it's not ready yet. So we have to wait a little bit. What we can do in the meanwhile, let's say we want to have a look at the log file. We can say kubectl log, and then the name of the pod, and it'll show us, what's going on in the log file inside the container. So this is a nice way, or a simple way, of just viewing to see what's happening. Okay, we can see it's already receiving some HTTP requests. So let's go back here, and here we go. Our WordPress app. So this in itself is not, I know this can be done in many ways, and it's not something amazing, but the interesting part is what you can do with the Helm charts afterwards to package your own applications. Now, the way you can do that is, of course, let's go back to this Helm chart here. This one is, you'll find a whole repository with Helm charts, and you can use those. It's under Bitnami charts, and you'll find, like I said, a range of different applications that are installed, everything from Jenkins to Kafka to MariaDB, etc., installed, using Helm. You'll even see things like Elasticsearch, etc., in a cluster. So MySQL as a cluster, etc., etc. And what you can use this for is you can use these to study basically how. Let's just find the WordPress again. You can use this to study how these templates are built up. Typically what you'll see is there's a service definition in a YAML file. There's a secrets. This is where typically we will store our secrets for username, password, etc. There's a PVC, which is a persistent volume claim. If it's something that needs persistence, you'll define the persistency here. There's an ingress. If you need a load balancer, typically you'll specify it here, or you need like, deployment, that's the actual application that's being deployed itself. TLS secrets, so if it's your certificate, if you need a certificate for the ingress, and the service, so what service is exposed. These together basically is the application. Now here you probably won't see any database, so you might wonder where's the database installation, and we only see the stuff here. There's also another file called requirements YAML. This basically can refer to any dependencies that this installation has. So in this case, they don't define MariaDB here. MariaDB is defined in a different chart. Okay, so because the MariaDB is defined in a different chart, we can just include it as a dependency and say, enabled. And this is basically like a parameter that goes to the value file of this dependency here. Now, another very, very clever thing, like I said, you can have these different value files. So you see here value production, value, and a default value file. You can easily change this. This basically has all the configuration parameters in one place. So, and the way this is passed on to the application is through environment variables. So every container gets an environment variable passed on to it, depending on whether it's exposed or not, of course, and whether it's, Helm chart is actually meant to expose it. But they are defined here. This allows us to basically really easily change an application depending on the environment or the setting it's being installed in. without having to change, what the actual stack is consistent of. Let's do a test where we change one of these values. Let's say we saw that our blog post here said user blog post. Let's say we want to call it Hassan, just for the sake of thinking, just showing how it's done. So the value YAML file has a place where this is defined. I think WordPress blog name. So what we can do is, let's go back to our cluster. Was it here? Yeah. And I've already downloaded the file here, the value file, but you can basically just download the file, only that file, nothing else. And let's go to the port, where's the WordPress blog name? And we can change that to Hassan. I can change that now to Joe. So let's save that. Now I'll do the exact same thing as I did before when I deployed, except that this time when I install, so let's call it test B. Instead, this time what I'll do is I'll refer to the file, so flag F, and then values YAML. So that'll pick up my YAML file and run the exact same chart and install it, except now that will use my local file. What this will do is basically use the file. So we should see in a second when we expose these things here, we should see the, it should say Joe's blog. Let's see if that happens. Okay, so it's probably not up and running yet. That's why it's giving me an error. So let's wait a bit. Okay. Coming back to Kubernetes, you've probably seen me like enter a few things for Kubernetes, and I think the easiest way to probably get an overview of what you can see and do is go to the cheat sheet on Kubernetes IO. You'll get an overview here, of the most common commands like get services, we show you service namespace, get pods, get deployments, describe nodes, describe pods, etc., etc. This I can highly recommend to go through this cheat sheet just to get an overview of like what's there. Also, get familiar with the resources. Kubernetes has so many different resources, everything from block volumes to the load balances to actual, even certificates can be stored in there for the load balances, there's cell certificates. And there's various tools to manage all these different things. So make sure to get an overview of these things, because that will really show you the power and what you can do with this, because essentially you want to automate everything. You don't want to leave or pretty much everything, or as much as you can. So by getting familiar with what resources exist, you'll know what sort of things you can manage through the Helm charts. Let's just do Q&A. There's a what's the difference between Helm and Terraform, or how is Helm any better? So Terraform is really for managing infrastructure as a service. So let's say I could use Terraform if I have a Kubernetes cluster. I just showed you that I created a cluster using the UI, the console. Now, if I didn't want to do that, if I didn't want to go through that step, let's say I wanted to have 5 Kubernetes clusters for different environments or different regions for DR, etc. And I don't want to do that manually. I want to make sure that they're all exactly the same. I would use Terraform to define my different, maybe VCNs, the networks, the subnets, maybe the users that I have in my cloud account. I could define all these different things, and also the Kubernetes clusters, and say Terraform apply to spin up, provision all of that. But then the next part is deploying or spinning up the applications on Kubernetes. So Helm would be for that part. Terraform would be for the infrastructure part. You could tie them up together if you want. So you could make Terraform run initially and then call Helm chart later on. That's something you can do if you want to fully automate everything, both provisioning the Kubernetes cluster and the application. But it's not like every day you spin up Kubernetes clusters. There's another question here. Can you share documentation lab to practice and start create my own Helm chart? Yeah. So is it? It sounds a bit complex. It of course there's a little learning curve, right? You have to, like I showed before, you have to get familiar with different components. But the starting point, I would say, the starting point is understanding the resources in Kubernetes, because you can't start using Helm chart without understanding the resources. Once you understand, all these different resources that exist, the concept of resources. So if I click here, you'll see here kind deployment. So this is a deployment resource. If I click on service, kind service. And if we go back to Kubernetes here and say, kubectl get services, you'll see that these are the various different resources. So first understand, the different resources. And the most basic ones are deployment, which is, I want to deploy this application. Like you state this is my deployment. The next one is I want to expose that application, somehow. You do that through a service. So those are the services. And you see it here, every single service here from, MariaDB, WordPress, they're all exposed on either on a cluster IP or an external IP. And you can see the ports which are exposed, right? So 3306 for, MySQL or MariaDB, port 443 and 80 for my actual WordPress app. And you can see here as well that it's a load balancer type. This is not by default, but what this means is the application that we spun up here, what it's done in the background is, if we go check our cluster and go to network and load balancers, what you'll see here is that it has spun up an actual load balancer. So we're combining two, you can see two worlds, right? We have the resources inside Kubernetes creating a container, but then it's telling the cloud, because it's running an OCI, hey, can you please create a load balancer for me for this service? Because I want it to be exposed with a load balancer. And you can look at the IPs and you'll see they should match. Test WordPress 138. So one of these 138, one of these should match. Oh, sorry, here. That was the internal IP, 90. Yeah, that's the one. The same goes for persistency. So if we say kubectl get PVC, so persistent volume claims. Now, what this will show us, it will show us that all the different volumes that we have attached to a container, and you can see the size of them here and the age, etc. And when I go to block volumes, you'll see the same amount of block volumes. So basically what this means is I could have created a container which, when I shut it down, it'll just switch off. But what we've done here is create a container and then said it has to be persistent, and it created a block volume in the background, attached it to the block volume. Okay, let's carry on. So we've created a Helm chart now. We have deployed WordPress, which is fantastic. Now the Helm charts. So like I said, we have the different resources. Those are here. Now the next part, which is interesting, let me just bring back my PowerPoint here. The next part, which is interesting and you should know or be at least familiar with, is service brokers. Service brokers and also operators. Let's start with service brokers. Service brokers is basically if you want to be able to spin up a PaaS service, right? So not like a load balancer, not a volume, which is kind of like very tightly coupled with the actual app, but a PaaS service like a database as a service, or as you see here, object storage. You want to make sure that there's a bucket created for your app where the images have to be stored. A service broker basically is the translator ambassador between Kubernetes and the PaaS services. And this allows you to do what? This allows you to actually, in the same Helm chart, say, my app requires an autonomous database, or my app requires also a bucket. And the service broker will make sure to go and speak to that specific service and create that for you. So it's basically just an extension to manage, other services in addition to the normal resources that Kubernetes can handle. Talking of service brokers, there's also another concept called operators. One of them, operators that I always use when I start using a service is there's two operators I use. One is Cert Manager, and the other one is external DNS. Cert Manager is used it can speak to Let's Encrypt. If you don't know Let's Encrypt is basically a service that can create, here we go, cert manager, let's go back. Let's say Kubernetes a service that allows you to create SSL certificates for free, rather than, yeah. And what Cert Manager does is you can install Cert Manager. It is an operator. So first of all, the concept of operator is that you install one container initially, for example, for Cert Manager, and then it will extend Kubernetes to understand a new set of resources. So what this will do is it will let Kubernetes understand the concept of certificate issuers, certificate, and a few others which are not here. And basically this will allow you to, on the fly, when you create an application, you can say this application, simply in the annotation of the application, in the Helm chart, say this should have an SSL certificate for this domain, and it will speak to the cert manager, speak to the Let's Decrypt service, get it to generate it, create this challenge, connect to it, and if it actually doesn't fail, it will actually create that certificate for you and add it to the load balancer. So all of that can be managed with Cert Manager, and it'll also keep an eye on when things are about to expire, make sure to renew them, etc., etc. So a lot of work, again, there automated with a simple operator. Now, this is not the only operator out there. Like I said, there's a lot of different operators. Another type of operator is external DNS. And what that allows you to do is basically manage your DNS entries. So again, you can say this application has these domain names, and make sure to enter, manage DNS for these applications. What happens is whenever a load balancer is spun up, and you get an external IP like we saw before, it will speak to the DNS service and create those DNS entries. So you get a full end-to-end managed application by using this. So coming back to the practical approach, I think the first place to start is take a really, really simple application, deploy it. Once you've done that, then go back and containerize your own application, create a Docker file for it, deploy it, and then go in and have a look at, like I said, things like a template. Start with a deployment template where you simply, in the first template, first of all, you'll simply exchange, you'll build it up around your image rather than something like WordPress, and enter your sort of like configuration values that you want to pass on to the service. This is basically the first step. And once you have that done, then you can start exploring like all these more advanced things that we've mentioned here, like operators and block volumes, etc. Okay, another example of an operator is the MySQL operator. It's really, really powerful, and it basically, again, rather than you having to manage MySQL, for example, on its own, what it can do is it allows you to both create backups, automated backups, schedule them, recreate MySQL from the backup, and be able to even have a full cluster running on OKE. I can see we are nearing the end of the time here, and I think I know it was a lot of info in a short time. I hope it's kind of been valuable, and if you have any questions, please ask them in the chat. I see we have one here. Can we use Terraform and Ansible to spin up Kubernetes? How is it different from Terraform and Helm Chart? Yes, you can use Terraform. So, for example, OCI supports both Ansible and Terraform, so you can use any of these to spin up resources. You can say Ansible and Terraform, how are they different? Well, it's two different tools doing, more or less the same thing. Ansible, I think, is really good at managing not just spinning up provisioning resources, but also the installation or configuration of applications on VMs. Helm Chart is very different from both Terraform and Ansible because Helm Chart is talking to the APIs of Kubernetes. You can use it to create, like I said, resources on OKE. I hope that answered the question. Any other questions? Instead of spinning up a new autonomous database, can we use Helm charts to talk to an existing DB? Yes, absolutely. I mean, if you already have a database, then it'll probably be simpler because it's probably permanent and you have an IP for it. So you can just add the configuration and endpoint in your value file, to what database your application needs to speak to. I'd say the advantage of using, let's say, adding the database in the actual Helm chart is when you spinning up a lot of environments and it's dynamic, then it's a bit easier to, you don't have to worry about those, or what was that specific database that this environment needs to connect to, right? So it makes sense for dynamic environments to have it like that. And also in case if any changes happens all of a sudden, especially with containers, you normally need to go and rebuild the containers and put in the configuration values. So by having them automatically configured, it's slightly easier. Okay, and if there's no other questions, then final thing, as an addition to the persistence that I mentioned before, I mentioned the block storage as the persistence, object storage through a service broker. There's also things like file storage where you get almost like an NFS share. We often see that with containers too. I think with that, I will say thank you for listening, and please do let me know if you have any questions.
So thank you, Hassan. Very interesting. Guys, if you want, there are a series of hands-on lab. I will share with you into the thank you email links that you can actually follow to try yourself. So there is the possibility to raise an Oracle Cloud Free Tier account and test with a trial the possibilities that Hassan showed to us today. So thank you again. The session will be available also on demand, and follow us for the next initiative on Oracle AskCom Office Hour Cloud Services. Bye-bye.